Okay. So like I said, pretty much just word problems of what we did yesterday. Make your notes out. Grab your notes. We got a bridge in China. That's old. So let's draw a bridge. It's a good thing I'm an artist. Oh, what a perfect bridge. Kind of. Okay. It says you can model a support arch with the function f of x equals some nasty numbers, but that's okay. I want to know how high is the arch above its supports. So what I want to know is this distance. This is about where our peak is, right? I want to know how high it is. Then I want to know how long is the section of the bridge above the arch. So I also want to know this. Okay? Those are the two things I want to know.
Alright.
What was the first thing we did yesterday?
You find
Find x.
Find x.
Negative b over 2.
Yes, perfect. X equals negative b over 2a. Like I said, our numbers are pretty nasty, but that's okay. My b is this 0.131148 over 2 times my a, negative 0.001075. If you put that in your calculator, you get about 61. Okay? So that's my x. That's my x of the what?
Of f and x. 61.
My vertex, the peak. So this peak right here, right? So my x is about 61. So isn't this distance 61?
Yeah.
Can I already answer by what we know about vertex? Can I answer how long this is?
Yeah.
How long is it? If this chunk 61, what does this chunk have to be? 61. So how long is it? Yeah, it's 122 feet. That answers that question right there. Okay, and then I'll fill this in. This x coordinate is 61, something. Okay, what do I do with 61? Plug it into that nasty stuff. I got y equals negative 0.001075 times 61 squared plus 0.131148 times 61. That's in parentheses.
Sheesh.
So yeah, it's nasty. If you don't write that down, you don't have to. Put it in your calculator. You get about 4. I know all that for answer 4. Crazy, huh?
I got a question.
Yes, sir.
How do you know, like, that bottom part? How do you know that's gonna be x?
What do you mean?
Like,
This?
yeah, you just put x there.
Well, it's just something we want to know. How about question mark? Is that better?
Okay.
And this is question mark. Is that better? Because it's not technically x.
This times 6 at the end,
Times 61. Plug our 61 in there. Okay. So my y is 4. So what do I do with that? Where does that go? It's the y of what? My vertex. So that means that this point is 61, 4. So what's the height of this bridge? 4. Hard to believe, but it is 4 feet high.
Short bridge.
It's like a little
What's small?
Toys R Us bridge. I don't know.
It's fit.
What's long?
Okay. How was that? Not too bad? Yeah, the numbers were nasty, but other than that, it's just plug in your calculator, right? Okay, we good here?
Yep.
Our next one says Marnie throws a softball straight up into the air. The ball leaves her hand when it is exactly 5 feet from the ground. The height h of the ball in feet can be written as a function of time t in seconds. H equals negative 16t squared plus 40t plus 5. Let's draw a picture. So I got a ball going straight up in the air. Okay? But is this point 0?
No, it's 5.
It's 5. So let's make our graph go a little bit further down. And this, I'm going to square this one off. Hopefully it's not too big. Ooh, like there. And this line is 5. Because it starts, where does it say that? 5 feet from the ground. Okay? So we're not starting at 0, we're starting at 5. Okay. I want to know what the maximum height the ball reaches. And Marty catches the ball 5 feet from the ground. How long will the ball be in the air? Okay. See. What do I gotta do?
K to solve for T.
You want to solve for T?
I don't want to. I see you have to solve for T.
What's the first thing we always do with these quadratics?
Five.
Find the vertex. We do that with our little x thing. What does x equal?
Negative b over two.
Negative b over 2a. My b is 40. What's my a? Good, negative 16. Put that in your calculator and we get out 1.25. So that's the x coordinate of what? My vertex. Vertex is always the peak. So this point right here, I know the x is 1.25. So if it takes 1.25 seconds to get from 5 feet to the peak, how long is it going to go from the peak to 5 feet again when she catches it? 1.25. So how long is the ball in the air? 2.5. Let's put that in different color. 250 seconds. Everybody know where we got that 2.5 from? Still gotta answer the question, what's the max height? How am I gonna do that? Plug it in. Plug it in. This, it's not technically called x, it's called t, but whatever. So we got our y, our height, negative 16 times t, which is 1.25, squared plus 40 times our 1.25 plus 5. All that calculator work. Your y is going to be 30. Where do I put that in my picture? Next to 1.25. And it stands for my y, which is how high this point is. So how high is it from the ground?
35 feet.
30 feet from the ground. Okay. Questions? let's go to the next one. Last one. It says write a quadratic function to represent the areas of all the rectangles with a perimeter of 36 feet. Graph the function and describe the rectangle that has the largest area. One question.
One before, actually, that would be wrong.
What?
Because you're calculating for the 5 feet up in the air. You can calculate the 5 feet. Here's at 5 feet higher. You don't calculate 2.5 for the vertex.
Do what?
The question was how long it would hit until it hits the ground. You actually only calculate until it hits the 5 feet. You didn't calculate until it actually hit the ground.
So we want to know how long it takes, how long it's in the air.
Until it hits the ground. You only calculate it for the 5 feet.
But it catches it 5 feet from the ground. So from 5, this is like your origin pretty much just moved. Because you can catch it at the same height. Alright, anyway, back to rectangles. First thing, I want to write an equation for the perimeter of a rectangle, given that it equals 36. Here's a rectangle with x, length y. How do I find perimeter? That's area. Perimeters are round.
You add
Add them all up, so like x plus y, aka 2x plus 2y, right? And what do I want that to equal, it says? 36. Okay. Second thing we're going to do is solve for y. So I want to get y by itself. So I'm going to subtract my 2x. So 2y equals negative 2x plus 36. Then divide by 2. Y equals negative x plus 18. Okay. What was I thinking? Oh, area of a rectangle. What's the area of a rectangle? Length times width. In our case, our length and width we call x and y. So it's x times y. But what am I going to plug in for y? Like we were just saying, Jay.
Y equals negative x plus 18.
Plug in what we just solved for y into y. Okay.
So now you just have x equals 18.
Now we got to multiply, right? These are all multiply. We have to distribute. What's x times negative x?
Negative 2x.
Nope. Negative x squared. 18 times x.
Negative 18x.
How about a positive 18x? The only reason that first one is negative is because this x is negative. We distribute this one. Okay. So we know A equals, have our area formula, all in terms of x, our width. Okay. All we gotta do is graph it to find our maximum area. To graph with these, the first thing we always find is what? The vertex. The x coordinate on my vertex. X equals what?
Negative b over 2.
Negative b over 2a. What is my b?
18.
What is my a?
Negative 1.
Simplify and we get 9. Positive 9, right? Negative divided by negative. Now what? Find our y, plug it in. A, same thing as y. Y equals negative 9 squared plus 18 times 9. Simplify and we get y equals 81.
Who came up with like a negative times positive equals a negative?
Greeks probably. Old people that are dead now.
I don't know if they had somebody who actually quoted it.
Probably. Vertex. Our point is 981. Now we just got a graph. On the x, I'm going to go up by 2s. Y's, I'm going to go up by 10s. Okay. So then I'm just going to plot my vertex 981. What? Who said wait? Nobody knows. So 2, 4, 6, 8. Like there-ish. Okay. Everybody got that plotted? Now just plug in 2 points. That should be an X. I'm going to use 12 and 14. If I put in 12, hold on, pause. Where am I plugging these in? The 12 and 14. Right there. Okay, let's plug those in for X. For 12, I get out 72. For 14, I get out 56. Now what? Ramp it. 12, 2, 4, 6, 8, 10, 12. Close enough. So we got something like that. Okay. Everybody have it graphed? 5 says, what point on the graph has a corner that represents the largest area? So largest, in order for largest is like max, right?
Yeah.
What's the max of the graph? 981. Our vertex, right? Vertexes always represent min or max. Okay, how can you find the coordinates of this point? Oh, we already did that. 981. I feel like we don't need to write it again. Describe the rectangle that has the largest area. So the rectangle would be 9 by 81. What is that area? Or I'm sorry. Hold on, pause. Sorry. Okay. This 81 was our y, right? What did y represent here? Our area. So our area is 81. So if the width is 9, what does the height have to be? Or I'm sorry, the length. 9. So a 9 by 9 rectangle. Our area would be 81. My bad, sorry about that. What? Yep. Square. Okay. Questions? Yeah, we're not. Oh, yeah, this. Well, because what are the coordinates? I feel like we've already written it twice, so yeah. Okay, no questions. We're